Welcome to Group 4's assignment on the Apriori algorithm for frequent item set mining. We will be using these three datasets: FIFA with 19k rows, wine reviews with 169k rows, and Yelp reviews with 6.9 million rows. As we're working with a large dataset, we will need to read our data frame in by chunks. We also use multi-threading to improve the execution time of our algorithm. To get our length 1 item sets, we will count the support for every chunk and compile the results together, then filter these results to get the frequent 1 item set. This will now be Fk, representing our frequent k item sets. So while this is not empty, we will generate the candidates from this set and prune the candidates. Now we will count the support for every chunk and compile the results as before, and then we will filter to get our frequent k+1 item sets. We will now do a demo of our algorithm on the Yelp's review dataset. We can see that the extremely large dataset of 6.9 million rows is being read in chunks. Now we'll move on to task 2, where we'll run our algorithm on the different datasets. Each transaction of the FIFA dataset corresponds to one player. For example, we have Messi with the following attributes. An example of a frequent item set mined would be the combination of these attributes. Looking at the run times for this small dataset, we can see that at very small values of min support threshold, that there is value in the disk-based version versus the non-disk-based version for candidate generation of frequent item sets. Here's a possible transaction for the wine reviews dataset. And here's an example of a frequent item set that was mined. The Yelp reviews dataset is similar, except that the reviews is on restaurants instead of wine. This dataset was extremely large and was not compatible with our other algorithms other than the disk-based candidate generation one. We'll now move on to task 3 and 4, where we cluster the transactions and try to improve our algorithms. For the FIFA dataset, we aim to discover whether any particular traits would significantly impact the value of wages offered to a player. We split the wages into 3 buckets: high, medium, and low. From these results, we can see that cluster 0 clearly belongs to high-wage players. However, it's not that obvious for the other 2 clusters. We then reduce the dimensions using truncated SVD, and our results improve as the entropy decreased from 0.91 to 0.86. We can also clearly see that cluster 0 corresponds to the high wage, cluster 1 for medium, and cluster 2 for low wage. This chart shows our frequent item sets as features in descending order of importance. Taking a closer look, we notice that having high passing mentality and movements is an influential factor in determining the class of wages. Here's a chart of the support for each item set across the clusters. As we move down the chart, we notice that those players in cluster 0 with high wages have high-level abilities, whereas those in the low wages cluster have low-level abilities. Moving on to the wine dataset, we wanted to find out whether the continent or country of origin will be associated with certain words. First, we set the continent as the target labels and ran the KNN algorithm. However, there's a severe imbalance where 45% belongs to European Union and 42% belongs to North America. This caused the KNN algorithm to struggle in clustering patterns for minority classes, possibly also indicating that the frequent item sets as features have no relationship with the continent that the wine was produced in. Next, we switch up the target labels to be the countries instead, and we run k-means and agglomerative clustering algorithm. We can see that each cluster has distinct distributions for the 50 countries, indicating that our clusters have some predictive potential on each wine's country of origin. We then apply dimensionality reduction techniques such as PCA and UMAP. UMAP clearly outperforms PCA as it continues to hold distinct clusters within the data, whereas PCA fails to capture our original data's patterns. With these improvements, our entropy decreased from 5.8 to 5.06. We'll conclude by looking at the clusters from the best result. Cluster 0 is on a sourish and fruity profile. Cluster 1 refers to wines with thick and viscous textures, while Cluster 2 could be for wines with a piquant or spicy kick. From this video, we were able to use Apriori algorithm to derive some insights on our datasets by mining for frequent item sets. We hope that you have learned a little something today. Thank you!